In this class, we're going to look at database consistency. So there are a number of features built into the database that we can use to make sure that everything kind of makes sense. We could, as programmers of the database, just promise not to do anything stupid ever. But since the database itself allows for constraints, it allows for rules, what we can do is we can trigger those so that if someone does try to do something that's kind of stupid, we might prevent them. So we're going to look at the database that we have so far, and then we're going to see just how we can improve that a bit. So Retrovision at the moment has 3 tables. There's a customer table for the customer details. There's a DVD table for all the movie info. And there's a rentals table that specifies who rents what. Now let's take a look here at our customers table. We have a primary key here. That's a numeric key, 1, 2, 3, 4 in this case. And we're storing the forename, surname, telephone number, email address, and there's a password. Now, you'll notice here that we have set the email address to be unique. So there can't be duplicates of the email address. And we've also set it to be not null. So the person must enter an email address. They don't have to enter a phone number in this scenario. Now, the value of requiring the email address to be unique is that if we have 2 John Smiths, we can avoid the possibility of creating 2 entries for the same guy if we get his email address. And so if someone walks into the store, "Hi, I'm John Smith, I want to open an account with you." We say, "Give us your email address," and we put in John Smith, and we can check the email address. And if that email address is already in use, so we can say, "Oh, hang on a minute, John, we think you're already a customer here." And so we can use that then as a way to prevent us duplicating entries for the same person. You could argue that the telephone number is equally good for that, or even better. Certainly, in a regular DVD store like from the 1990s, if we go back in time, people shared phone numbers. But now that everyone has a mobile phone, people tend not to do that anymore. So we could say really, well, phone number is equally good for that purpose, or perhaps even better. So that's why we've done that there with the email address. And that's the thing we would need to do. So if a John Smith comes in, we want to add John Smith to the table, we do have to check he's not already there. And of course, there can be lots of John Smiths. John Smith's a fairly common name. Because the email address is unique, and because even we could if we wanted to make the telephone number unique, we could really have decided that either one of those could have been the primary key. But if we did that, a person could never change their email address or never change their telephone number. That wouldn't be desirable. Now, in the 90s, people changed their phone numbers, all right. People tend not to change their phone numbers anymore either. But even so, this is why we've done it this way. So someone can change their phone number or change their email address, and this will all still work. But the requirement there to make email address unique, I need you to understand why that's there. Next up now, we have our table with the DVDs. And so each disc, gets an ID. And we are storing the title, the year the movie was released, and the rating. You'll notice there that the rating uses enum, so it can only be one value from a specified set of values. And also we've set the default there to 18. The logic behind that was if we don't have one in the database, if there isn't a rating entered, well then we'll default to 18. So something is 18 unless proven otherwise. And then that will preclude the possibility of renting 18's movie to like a 12-year-old or something. So that's the logic behind that. Obviously, a movie with no title is kind of a bit pointless. What would there be the point of having that in our database? But we don't need the year. We don't need the year. We do want the rating, and if we don't get a rating, we're going to assume 18. So that's the DVD tables there. Now we're going to look at that a bit closer and have a think about what's going on there. So if we look here at movie 4 and movie 14, so Central do Brasil appears twice. That's because we've got 2 copies of this movie because it was so popular. And that's a perfectly reasonable thing for a DVD store to have. So a person could rent 4, or 4 might be out, 14 might be out. If we've got the same movie 2 discs, we can rent the same thing twice. Now there is an issue here. A database guru looking at our table might have an issue with the fact that there's some repeated data. She might say that wherever you have data duplicated in the database, that's a sign that something's wrong. That's a sign that the database is not normalized. So we could do a couple of weeks really work on a normalized database and how you would normalize a database and what the process is, what the steps are for that. But when you think about it really hard, it all kind of makes sense. And so what I'll do is I'll explain to you what would happen if it wasn't normalized, and then you can see what that kind of looks like rather than be very formal about it. So why is the lack of normalization a problem? What could go wrong? Well, it allows for the possibility of inconsistent data. So let's say somebody changes the year of disc number 4 to 1997 and changes the rating of disc number 14 to 15A. Well, now our database is really storing inconsistent information. I mean, the database is telling us that Central do Brasil was released in 1997, and it's telling us that it was also released in 1998. It's telling us that it's 18s, and it's telling us that it's 15A. I mean, which is it? And this should never be allowed to happen. Now, one solution to this is we make anyone working on our database promise that they will never, never, ever do anything so stupid as this. But at the end of the day, really, it's a problem with the database design. It hasn't been thought through properly. It hasn't been thought through thoroughly enough. And so let's have a think at maybe taking the database design to the next level. So we can have many copies of the same movie. That's fair enough. Like, we'd be losing out on money if we only had one copy of a popular movie. If we're going to rent 10 copies a night, then we want 10 copies of the same thing. And each disc can be rented separately. But when a person is renting a movie, from their point of view, they're renting the movie. They're renting Central do Brasil. But from a database point of view, they're just renting the disc. And that's not the same thing. So each disc is rented separately, but we only need to keep track of the movie details once. We only need to keep track of the fact that Central do Brasil was released in 1998 once. And so really what we need to do is we need to separate the discs from the movies that are on them, which conceptually is difficult, but from a database point of view, they're two completely different things. And so if we look here, we have two tables. We have a table for the DVDs, and we have a table for the movies. And the DVD table, that has a list of all of the discs. So the DVD ID is the primary key there, and that tells us the ID of the disc. And then move ID, that's associated with each entry there. So each row of the table has a disc ID, a DVD ID, and a movie ID. And then we have a separate table that tells us about the movie titles themselves. And so we can see here that DVD 3 has movie 3 on it. So we can see then that disc DVD 3 has Star Wars on it. We can see that DVD 4 has movie 4 on it. That's Central do Brasil. And we can see that DVD 14 has movie 4 on it. So it too has Central do Brasil on it. So we can see there then that we're only storing information about the movie once. And the movie is distinct from the disc. So now if we know that someone has rented disc 12, we are actually kind of one step away from knowing what movie they rented. We have to go to the DVDs table, see that they rented 12, see that was movie 6, and then go see that movie 6 is 50 Shades of Grey. So it's a bit more work, but it makes more sense, and it removes the possibility then of some major inconsistencies in the tables. Next up now, we're going to have a look at the rentals table. So this is a table that's going to keep track of who's renting what. And there are a couple of ways to do this really. And again, what we have at the moment hasn't really been properly or thoroughly thought through. So we have an ID here, a primary key that's an int, and that's telling us just the rental ID. We have a customer ID, and we have the disc ID, and then we have the date that the movie was rented. Now, so our database guru, if she came back and had a look at this table, she might say, well, now I'm not sure about that either. If you think about it, like the customer and the disc combined could be unique. That could be a composite key. So what's a composite key? A composite key is a combination of attributes that when they're combined could act as the primary key. And so the question is, could we use the customer details and the disk details combined and have that as the primary key? Would that work? And the answer really is it depends actually on what it is we're trying to do. So the first question is really, do we want the rentals table to track all of the DVDs that are currently rented, that are currently out? Or do we want a log of the rentals over time? Because those are two different things actually. Okay? So suppose we only wanted the table to keep track of all of the DVDs that are currently out. So the idea is that a disc is in this table if it's rented. This tells us who rented it and the date they rented it. And when the disc comes back, it's not rented anymore. so we delete it from this table. So if that's what we're going to do, if the rentals table is just the list of the current rentals, well, in that case, actually, because the disk can only be rented then to one person at a time, the disk alone could act as the primary key. Because the disk is never going to be, the same disk is never going to be rented twice at the same time. So no disk is ever going to appear in this table twice. Because when it's rented out, it's in the table. When it's returned, we delete it from the table. And then we might rent it out again. But when we're renting it out the second time, it's still only going to be the only instance of the disk in the table. So if we wanted a rentals table that was just going to tell us what's out now, this would be fine, really. The disk is all we need to know about, and which customer has it and when they took it. If it's not in this table, it's in the store. That's the idea. So that could work quite well. In that scenario, you could use the disk then as the primary key. Now, if we want a log of all of the rentals over time, well, then that's a different scenario. So if we look here, for example, disk 5 was rented to customer 3 on the 1st of the 1st, 2018. And then disk 5 was rented out to customer 1 on the 15th of the 3rd, 2018. So in this scenario, because we're keeping a log of what was rented, the same disk can be rented many times, but it could appear then in the table many times, because we're not deleting it when it comes back. We're keeping it in there. So in this scenario, the disk can't be the primary key all by itself because it needs to appear more than once. But if we were to combine it with the customer table, with the customer column, the combined key could be the primary key, but the only catch there would be no customer could ever rent out the same disk twice. And if you think about it, I mean, that's a possibility. You know, it's possible that someone rents a disk, loves the movie, brings it back, comes back a month later and says, I really love that, I want to rent it again. Now, if we have multiple copies of the disk, multiple copies of the movie on different disks, well, then they could maybe, get lucky and get a different disk. But if they came back to rent the same disk, then it'd be the same disk with the same customer number. And that would basically then blow up our table, because that can't be the primary key. And, that's a thing that people do, or used to do when they rented DVDs. They would rent the same thing maybe more than once. So at first glance, it really does look like the disk and customer could be a combined key and be the primary key that way. But if you think about it really hard, no. So as it turns out, the answer to our question is no, actually. Just no, it can't be either way. So we do need a unique identifier if we're doing the historic log rather now. So if we're doing the table of like what's out now, then the disk is the primary key and nothing more. If we are keeping a log, then we need an ID for each rental. Then we're going to store the disk and who rented it. We're going to store when they rented it and when they returned it. I've also chosen here to use the time they rented it as well. So I'm doing a bit like a car rental. If you rent it at 6 o'clock on Monday and you're only renting it for one day, well, then it has to be back before 6 o'clock on Tuesday. So I'm being a bit of a bastard here, but then again, that's how DVD stores made their money, I think. That's one of the reasons why Netflix became so popular. Back when Netflix was a DVD rental business, before we only had streaming Netflix in Ireland, but in the US, Netflix entered the business with DVDs first, and there were no late fees, and people thought this was wonderful, because DVD stores were really screwing people. So anyway, I'm going to screw you here, and I'm going to put in the time as well that it was returned. What we could do, I guess, in terms of keeping track of what's rented and not, we could leave the returned null in the meantime. So if something was rented but returned is null, then that means it's still out. So that could be the way to do that, for example. So that's null until such a time as it comes back. So in this scenario then, rental number 1 was disk 5 to customer 3. It was rented and returned. And then rental number 3 was disk 5, customer 3 again. And so the same person can rent the same thing twice. So if we look then at the SQL for this, we could create this table by saying create table if not exists rentals. So we have ID, which is an integer, and it's going to auto increment, and it's the primary key. We have the customer, that's an integer, and it's not null. Like, without a customer in the table, it makes no sense. It's pointless. Like, it's no good to us. Why would we have it at all? Then next up we have the disk, and that's an integer also, and that's not null. Again, like, it makes no sense not to have the disk they rented. We have rental date, and that's date time. So that's different from just the date. Date time is the date and the time combined. And once again, that's not null. And again, if it was null, it would make no sense. So this person rented this disk sometime, not sure when, that just wouldn't work for us. But we can leave the return date null. So what we can do is we can leave that null until such a time as they bring it back. And so that would work. That would be fine. Now, we still have some work to do in terms of the consistency of the database, though. So if we go back now to our DVDs table and our movies table, we've seen that here that DVD 4 is movie 4, which is Central do Brasil, and DVD 14 is also movie 4, also Central do Brasil. And that's fine. And the movie ID in DVDs, that tells us what movie's on the disc. Now, that's great. That makes sense. What happens if we delete item 4 from movies table? What happens? Now we have a DVD in the DVDs table with no title. So if the ID in movies is being used by the DVDs table, we shouldn't allow it to be deleted. That just shouldn't be allowed. Now again, we could make all of the programmers using our database promise they would never do anything so stupid. But we can actually hard code this rule into the database. And so if someone tries to do that, they'll be told, no, go away. So if we look here at the code for when we create the table, so here when we're creating the table DVDs, we're saying create table if non-exist DVDs. So we have the disk ID, we've seen that. We have the movie ID, and we've seen that, that's no problem. Neither of those are, well, the primary key can't be null, obviously. That's the disk ID, and the movie ID can't be null either. No. Here we're saying that there's a foreign key in this table. So a primary key is the important key in the table that uniquely identifies each row. If a column contains the primary key of a different table, that's known as a foreign key in this table. So in this table, movie ID is a foreign key. And here we're saying that that's a foreign key. It references the ID in the table movies. And we're saying on, update, cascade, on, delete, restrict. And what we're saying here basically is that we won't allow you to delete ID from movies if it's being used here in the table DVDs. We won't let you do it. So if you want to delete some entry from movies, you'd have to make sure to delete it from DVDs first. And that way then we can make sure that we never have a DVD that has a movie ID that doesn't exist, because that would be bad. That would be stupid. Now, the same issue comes up here with the rentals table. If we look here at the bottom left, we have our rentals table where we have the ID, we have the disk, the customer, the date the disk was rented, and the date it was returned. Now, the disk here is a foreign key that points to the primary key of the DVDs table. And the customer here is a foreign key that points to the primary key of the customers table. So can we allow DVDs to be deleted from the DVDs table? So if there was an attempt to delete DVD ID 2 from the DVDs table, that would pose a problem for us because that disk 2 there is being used in the rentals table. So if we allow DVD ID number 2 to be deleted, it's going to cause a problem in our rentals table, because we'll be talking about a disk that was rented, but we no longer know what disk that was, just that it was used to be disk ID 2. So we really shouldn't allow any deletions from the DVDs table if they appear in the rentals table still. What about the same question, but for the customers? Should we allow a customer entry to be deleted from the customers table? So if we look here, if we want to delete customer number 3 there, ID 3, well, that's going to cause a problem because that customer has rented disk 5 and rented disk 2. There's 2 rentals there. And so there is an argument that those customer details should never be deleted as long as they are in the rentals table, because that would cause a problem because we couldn't see then who rented what. However, if you think about the way this might happen in real life, the way data protection laws work, and just, I suppose, common sense as well, I mean, it's perfectly reasonable for a customer or a person who is no longer a customer even, to have their details deleted. So let's say, for example, a customer requests to have their account closed and their details removed from the system. They're entitled to do that legally. But also, let's say someone hasn't rented something in 5 years. Now, I guess there came a time in DVD stores where no one rented anything for 5 years. It's part of the problem. But let's say someone hasn't rented anything for 5 years. You might say, look, we're going to do a bit of a cleanup. We're going to delete all the people who haven't rented anything in 5 years. In a way, it's not such a big deal if the customer details are no longer there. Because we can still see, for example, in the rentals table, like that, such and such a disc was really, really popular, such and such a movie was really, really popular. We still have a lot of useful information. So I would say from a database point of view, deletion shouldn't be allowed in either, but sort of from a, logical thinking it through point of view, okay, a DVD should never be deleted from the DVDs table if there's an entry for it in the rentals table, and you should require the programmer to delete the rental record before you delete the DVD record. But deleting customer details is probably okay. It still creates the same technical problem, but it's not as big a deal. So we could use similar code to what we used for the DVDs table in order to make sure that inconsistency doesn't occur. And the important point about these rules is that these are rules that are internal to the database. So if somebody tries to break these rules, if someone sends code to the database, say do this or do that, the database will just say no, it'll send back an error. And we can have a look at some of that now and just see those errors actually kicking in. Now here we have the code for the, new and improved DVD website or rental site, and so this isn't Retrovision, this is Metrovision, and this is the file that I'm going to give you so that you can complete the final part of the assignment. So this is the code that creates the database. Let me show you how to do that. I guess what I'll do is I will delete it now. Let's see. So I'm going to do not try this at home. Drop. Okay, see if that works. Did I do it? See, that's live programming for you. Okay, so that's gone now. Okay, so to create the database from scratch, you're going to click here, I guess, and you're going to take you can take all of the code, but actually what I would like you to do is I would like you to do it piece by piece, okay, just so you can see the effect of it. So here we go into SQL, and we're creating Metrovision. Now you can see we have a database Metrovision with not a whole lot in it. Here we're creating the table for the customers. Make sure then you click on Metrovision before you go slapping in the SQL. Pop that in there. It's good to go. Now I have lots of customers here. I've actually created a slimmed down customer table for the assignment, so it just has the first name, surname, telephone number of date of birth, and of course the primary key, which is an ID. And here I'm inserting into customers just the forename, surname, telephone number of date of birth, and the auto increment is going to handle the assigning of the primary keys. If for some reason I really wanted to manually set the IDs, I could do that, and I've done that later just to make the DVDs table a bit more interesting. But of course it would be my responsibility then to make sure that I never duplicate any IDs in the primary key ever, because the attempt to do that then would fail. I have two John Smiths here with the same phone number. I'm going to fix that right now. I haven't put in the constraint that would have prevented that. So that would have been unfortunate, because that would have looked like a duplicate. Make sure they give them different years, well, give them different years as well. No, it's all right. Now we're good to go. So if we copy that in, just make sure again it's on Metrovision, paste that in there, ta-da, and now we can look at the customers table here, And we can see, look, we have John Smith, these various films. So we can actually look at the tables and we can see everything's in there. Yippee-doo. Next up now, I'm going to create the movies table. Now this is separate from the DVDs table. And I've already talked you through this code. The interesting thing here is the enum, where it can only be one of those things. SQL. And away we go. And now we have, you notice here you can't see it. You might just need to refresh there to see the new table. There we go. Now we have the movies table. There's nothing in it yet, so no cause for concern. And now, have I said that the title should be unique for the movie? Yes, I have. So first of all, I've said obviously it can't be null. A movie with no title is no good to us. I've said it has to be unique. So if Titanic is already in the table, any attempt to add Titanic will be refused, which is what we want. So before adding a movie to the database, you would have to check if it's already there. If it's already there, you can't add it. If you try to add it, you'll get an error, and you could kill your code and could crash over and die. But obviously your code would be written in such a way that that wouldn't happen. Just give that a go there. Everything's fine. So just put a bunch of movies in there. I actually went to the trouble of getting the years right, but not the ratings. Now, this is the interesting bit here. We're creating the table of DVDs. We have the primary key for the disc. We have the movie ID. But we're saying here that movie ID is a foreign key that references the ID of the movies table. And this bit of code here stops us from deleting something from the movies table if it's being used by the DVDs table. So that's quite interesting. A bit complicated, but interesting. Let's slash that in there. Now you do that when you're creating the table. You can also modify the table later, update it, but it's handy just to sort all that out in advance. Here I'm just showing you a couple of different ways stuff can be entered. So here I'm entering the disk ID manually. So I'm saying disk ID number 1 will be movie 1. We can see the effect of that. So we can do that if we want. Now we can go look at movies. Oh no, sorry, not movies. We can look at DVDs. And disk ID 1 is movie ID 1. We can also just add a movie ID to the table. And of course the auto increment will give this number 2. And if we go to DVDs now, we can see that disk number 2 is movie number 5. Here, you could, in real life, what you would do is as you add a disk. So you would have like a page where you can add a disk to the database. You would put in all the details. It would generate the movie information if it wasn't already there. If it was already there, it would tell you. And then it would associate that with the next disk number. Okay? So you would end up with just sequential disk numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now it may happen then that you delete disks over time. Disks get damaged, disks get lost, whatever, and they're not in the store anymore. So that's a more realistic way in which the information would get entered. I just have doing it this way so we can have a realistic looking table where not everything is in order. So can we go to SQL? It doesn't matter where we go in the SQL as long as we're in MetroVision. So just a bunch of values in there. And then we can go look at our DVDs table. And you can see we have lots of DVDs. Excuse me. Lots of DVDs, in fact. And various movie numbers. Now, one constraint we haven't considered is that, well, no, I'm not going to talk about that actually. No. So the constraint I'm interested in now is, we can also add a few more here, just to show you. We're just showing the different syntax for adding. Again, we're just adding some more movies here. Just want you to see the different ways it could be done in SQL. And then we got a few more DVDs in there. Not even going to look at those. Now, what's interesting, okay, is this piece of code here. Now, I've commented this out in the file I'm giving you because, of course, it's going to fail. So if we go to our tables here, we've got a movie called ID number 10, which is Flashdance. How dare they try and delete Flashdance? Okay. So the problem with deleting movie number 10 is that the DVDs table uses movie number 10 for disk 13 at a minimum. I guess, can we sort them by ID here? Yeah, look, we've got 1, 2, 3, 4, 5 copies of Flashdance on various discs in the store. Great movie. So if we delete title number 10, if we delete movie number 10 from this table, there'll be a bunch of discs in the DVD table with no title. So that would be a dumbass move. Let's give that a lash and see what happens. Oh yeah, that's just, no, that's not what I'm trying to show you. That's just the page here. It does that for any delete, just to make sure you're sure. That's not what we're looking at. What we're interested in is this here, look. You said delete from movies where ID equals 10. We said cannot delete or update a parent row. A foreign key constraint fails. And said Metrovision DVDs constraint. Don't know what that means. It's a foreign key for movie ID references movies. So basically, the database caught this for us. It said it's saying you told me back when you created the DVDs table that the movie ID was a foreign key from movies, and that you wanted to restrict the deletions of that so that there weren't any inconsistencies. So even if the programmer tells the database to do that, it'll refuse because it's a bad idea, because we put that constraint in there. So let's comment that back out, because we don't want to try that when you go to set up your thing. Okay, so that's pretty much everything we need to know about databases, for our purposes anyway. Undergraduate students might do 3 or 4 whole modules on databases. So databases is a big area. But that's enough for us to be getting on with. You'll notice we haven't seen any PHP in this at all. This was just all about using SQL to set up the database and to communicate with it. And that will be independent of whatever programming language you might be using. So SQL is kind of a standard that's been around a very long time, and we can use that to communicate with databases. The next thing we're going to know is we're going to look at using SQL within PHP to request information from the database and then deal with it when it comes back. So that's the next task, connecting PHP to the database and then sending the database SQL.